All right. Well, it's great to see all of you in class today. Happy Monday. I hope everyone had a pleasant weekend. Today, we're going to pick up with oceanography. We're going to start looking at the history of the Earth and fold in a little history of oceanography. I would like to thank everyone who got the work in on time, the orientation packet that was due this week, the email agreeing to the syllabus, the quiz acknowledging you've read it, and lastly, the honor lock. There's a couple of stragglers on the honor lock. A couple contacted me and I advise you to, I'm not an employee of honor lock. Honor lock is contracted by the college to proctor exams. So it is a requirement to get that done and get that installed on the test. You may have to contact honor lock if there's a problem with your computer, your technology, or anything along those lines, because I'm not an honor lock employee, so I don't have any in to get you in there except point you in the direction of handling it. The reason we do that is a couple of things. First, people like to wait to the last minute. And when it comes to a midterm and you're taking a midterm, say on a Saturday, you don't have honor lock installed because you've never done it and it doesn't work. You tend to panic. You might not get the midterm in on time, or you might be so flustered, you just do poorly on the midterm. So we handle this honor lock business week number one being, I mean, it's a pain, I know. It's a third service proctoring party or second service, whatever they say that, you know, it can be tricky. You don't require a password, but if you get to that screen, you did something wrong, it's generally operator error and you have to reboot it and redo it. But once you get it on there and you know it works and you've gone through it, it's free points as a quiz because it's just 4 easy questions. And you know, on the midterm and the final, you don't have that to worry about. It's already installed. You already know how to do it. You've already done it. You concentrate on the work. And that's why it's important. And it's required by the college to have proctored exams and science classes. So there's no getting around it. Even if you didn't get it done, you got a 0 in the grade book now. Some people contacted me and of course you'll get credit because you know you tried before the due date. But even if you didn't, just slipped your mind, I dropped the lowest, that'll be the lowest. You still have to get it done because it's still required for midterms and finals. And I don't want anyone left hanging out there come midterm and final time. So that you gotta make sure you have that. We'll start off this week and we will look, we'll go to our homepage. Pop on the oceanography front page here. You can see, according to our schedule, our flow chart and discussion forum number 1 is due Wednesday at 11:59. Hopefully, everyone has posted their first discussion so people can read through them and we get a decent discussion going. Remember, you do have to respond to someone. I'm looking for full paragraphs, well-written. Until, you know, you can criticize as long as you're polite, you know, not necessarily, you know, controversial topic here with observing a photograph and then coming up with a hypothesis. But someone may think that your hypothesis is wrong and that's okay. Remember, in scientific method, it's okay to be wrong and it's okay to look at other people's opinions. So that's fine. Make sure that you respond to somebody in a full paragraph, including, you know, you can compliment or say, hey, you know, I think you're off base, but make sure that you include your scientific point of view in it as well. That way it's not just a, you know, compliment or a criticism, but it's a valid response. The sooner you get that done, sooner you can move on. Flowchart as well. The flowchart should be submitted as, now you can do one file and have the chart and then your paragraph underneath that. You can do 2 different files. It does not make a difference to me. You can draw the chart, take a snapshot of it, send it on your phone right into the Dropbox, and then type a Word file for your paragraph. That's fine. However you get them in, that's fine with me. Just remember you have 2 things to do, the flow chart and then your description. Don't just turn one in. That's the most common thing, is that people turn one thing in and then you can only get half credit. And it's a super easy assignment. There should be no stress whatsoever. It's filling in the blanks on a chart and talking a little bit about the scientific method. So let's get those in as soon as possible. So moving on, just a quick review because we're still early in the course. When you click on the course content, you see our Zoom videos. There's our first 2 lectures. Today's lecture will be on the video as well. It's going to be there when we're done. So to review everything, there it is. The midterm module we are in. Here's our lectures. We've already done the cartography. We're going to do Earth's history today. Those lectures are for you, so you don't have to write everything down. On our activities, you can see we have 2 things due next Wednesday, because what I try to do is I brief you on the assignments, the Monday, then I give you to the following Wednesday to get them done. In case you have questions, you can email me. You can ask me in the class, and asking in the class is great because then everyone hears the answer and everyone benefits. So you can do that. You have a module quiz due. Okay, it's a 45-minute quiz, multiple choice based on the reading and the class lectures. It is open book. You may use your textbook on it if you have the textbook. You can use your notes and things. This is not an honor lock test, so you can have your book and things like that. So it's a quiz based on the material in this module. You also have a current event, and we'll get into current events right now. Before we begin our, hold on for 1 second. Before we begin our, sure.
May I ask a question?
Well, yeah, go ahead.
Thank you. There, when I
okay,
see
1
my
second. Let me see
yes.
who you are first. I love
Maria.
to. Okay, Maria. Yes.
There's syllabus quiz, and it's some in my grade. I see lowest grade dropped.
Yeah, the lowest grade for each unit is dropped. If you've done everything and have 100s, then that'll be dropped. As you move through the course, let's say you get an 87 on something, then the 87 will be dropped and the 100 will move in. Right now, your lowest grade is 100, so that's the one that's dropped.
No, it's okay. I'm not need to do nothing. Or it's something.
You're fine. You're fine.
Thank you.
Yeah. All right. Okay, I popped open the module assignment, the current events. The topic that we're going to look at, the current events, is using satellites, GPS or GIS in the field of oceanography and climatology or any other new technologies. You should submit a Word file for me or a file in a Word compatible. You should have a cover page with your name and the class on it. You can include a picture and get zippy, or you can just write the title. The title could be using satellites, GPS, GIS in the field of oceanography and climatology. And then you need to find 2 articles. They do not have to be scientific journal articles, okay? We're not a graduate level class. We're an introductory 2000 sophomore level in college class. It's okay to use Discover or National Geographic or a newspaper article. So just bear in mind, you don't have to go to the ends of the earth to find scientifically scholarly articles that you need 3 PhDs to understand. Okay, we're looking more for everyday science, everyday oceanography. We're trying to build our scientific literacy and scientific knowledge, put it with current events, things that happen today. So, you know, big things in oceanography, receding of the glaciers, rising of the sea level, climate, that's why I included climatology. There's all different new technologies, satellites being launched. So your job is to find 2 articles, new technology dealing with oceanography and climatology. They don't have to be scholarly, but they can. Read them, describe in paragraph form now, write the article, the title and the author, describe the science in the article, topic sentence, 3 to 4 spotty sentences, and then a conclusion and summary. So that's 1 paragraph. Second paragraph, describe your position, experience, or conclusions. So basically, you have cover page, title, author, 2 paragraphs, title, author, 2 paragraphs, and then works cited underneath. The APA is required. APA is a style that science, psychology, social sciences use, Englishes and stuff use the MLA mostly. And you put that 2 APA entries, 1 for each article in there. The reason we're formally citing is so you learn and get used to formal citations. You'll be using them your entire college career. So citing formal is more than copying and pasting a URL and throwing it at the bottom. That's how we learn how to do it, is by doing it. And then, so basically you're gonna read 2 articles, review them, 2 paragraphs each, cite them, turn it in. That's your assignment for next Wednesday, that and the quiz. Are there any questions regarding the assignment?
Yes, how long should be each paragraph?
4 to 5 sentences, a body sentence and conclusion.
Oh yes, thank you. I'm sorry. Yes.
No, you don't have to be sorry. That's fine. That's a good question. People want to know, and that's why I put it there.
I have a question.
Of course. Who are you?
Alexia.
Alexia. Very good. How can I help you, Alexia?
Yeah, how many words are we supposed to write?
Oh goodness, I can't count words. I got so much better things to do with my time than count 50 kids' words. 2 paragraphs each, okay?
Okay, yeah, I just wanted to make sure because some of my other classes are like, hey, you got to write like 1,000 words. Or...
Oh, good Lord, I can't count that high. Anyone else?
Hey,
Okay, who's me?
Jalen.
Jalen, excellent. How you doing today?
I'm doing good.
Good.
It's for the quiz. How many attempts?
Yeah.
1. Oh, 1.
Oh yeah, it's open book.
Yeah.
And I mean, it says it's a timer, but if you run a couple minutes over, it's not going to kick you off and fail you. And I mean, if it were a closed book test, I wouldn't mind giving you an extra attempt, but being you can look everything up, just give yourself an hour, hour and a half, sit down and do it.
Okay.
Okay?
Yes. Thank you.
Yep.
Yeah. I got a question.
Yes. Who are you?
David here.
David, how are you today?
I'm waving at you.
Oh yeah, I don't see you because I only got the top 4 students on there. So
Okay, anyway, so the due date you referred to just now is 1 September for these these scientific articles?
That is, yeah, September 1st, correct.
Okay, I got another question. When I was trying to view the videos that you presented last week in your lecture, and
Which videos are you referring to?
the
Oh, that
lec-
the discussion forum?
no, you gave a lecture for the hour on
Okay, yep,
and that was put on as a recording.
okay.
And then I tried to open it and look at it, and it just froze. I don't know if anybody else had is that because of my download speed, or do I have to go to the college to get a better?
Well, I would not be able to, I don't know, I couldn't tell you why. It might be your download speed, it might be your computer. You know, I really don't know what we're dealing with. You might want to call the help desk. The college does have a hotline to help students with technical issues.
That's
Probably
okay.
something I wouldn't be able to answer for you. I know I downloaded it and tested it, so it's good from my end.
I also had trouble, finding things like, for example, where in the world would I find that TED lecture?
Can you hold off till class is over, because I'm happy to walk you through it, but I want to hit the lecture for all the students here, and then you can hang back and I'll walk you through it at the end, if that's okay.
Yeah, that's fine. I'm happy to do that.
Perfect, perfect.
And one more question, Maria.
Yes.
It's about these paragraphs. They say, describe your position, experience, and conclusion. It's my experience with navigator in ocean.
I don't know what you're asking. Let me just give you an example, and then move on. Let's say you find something dealing with the melting of the ice caps, and it's telling you that the increase of carbon dioxide by humans are melting the ice caps. So you want to describe what you think about that. Yes, it's the humans, or maybe it's more than that, or there's other factors involved, or any experience that you have, and the conclusions, your conclusions of this article in paragraph form. Everyone's is going to be different, so you're not going to have the same as, say, Hayden would, or the same as David would, and that's okay. I'm not going to tell you what your experiences or your position should be. I'm just going to read what they are.
I got one more question, Professor.
Yes.
Where do you find the protocol for implementing this APA? I don't know what that is, and I don't know where to start finding it.
Well, you can use Google and type how to APA, and there's very many resources there. Also, there's online bibliography services like EasyBib that you can use and fill in the blank from that.
Okay, thank you.
Formal citation that is used in many bibliographies.
Thank you.
That's a fantastic question. I'm happy you brought that up. So everyone here knows you can go to easybib.com, and then Purdue has something called OWL, O-W-L, that will also discuss how to APA site. If you have any APA questions, that would be a great place to start.
I would just add that under the My Courses tab on the SBC website, if you just scroll down a little bit, there's like the learning resources, and one of them is the library resources and services, and they have a whole section on how to do APA on
That's
the
fantastic.
college website.
Who do I get to thank for this? Because I don't have your name pop up.
Clayton.
Clayton, thank you very much.
Uh-huh.
That is that's great to know. I'm going to make note of that myself. All right, let's take a look at today's lesson. We're going to begin with a little bit of Earth's history. Okay, so I can't pretend to have every answer. I don't think anyone does. Remember, we talked about theories last time, and we're going to address the theory of how the universe began, and then we're going to look at some of the evidences of that, what the scientists point to as why they think what they think, what points them in that direction. Remember, theories are always changing, so take it with a grain of salt. We really don't know everything, even though a lot of times people pretend we know everything or get offended by what other people know. We'll start off with what's known as a joke, really, the Big Bang Theory. The Big Bang was a joke used to kind of needle scientists when it was first proposed that the universe came from a explosion-like event, causing it to expand outward. Its opponents laughingly called it the Big Bang, and it stuck. So everyone is familiar with the term the Big Bang Theory. Now, what are the evidences for that? Well, E equals mc squared, Einstein's equation, tries to explain it because it relates energy and matter, that if you have energy, as you change its properties, i.e. its speed, slow it down some, you get matter. And experimentally, energy and matter are related. For instance, you watch science fiction, which isn't experimentally, but you hear him say, oh, the speed of light, warp 2, warp 3, warp 4. Matter ceases to exist at light speed. As far as we know it, it's a photon. Light is got properties of matter, but then properties of energy. And the upper limit of speed, as far as we know, is the speed of light. So you have energy. Energy can beget matter. It's linked by Einstein's equation. So the beginning of the Big Bang, if you will, energy formed matter. The first matter was very simple, not even atomic structure. As matter began to congeal, what pulls it together? Gravity. We have nebula. Nebula are huge gas clouds. And as the nebula collapses, congeals, and we can witness this happening today. You know, we can't go back in time, witness the Big Bang. People study waves. People study the outward reaches of the universe, looking at the oldest objects in the universe because the universe appears to be expanding due to the redshift. The redshift is backing that up. The outer reaches are the oldest. And you kind of look back in time by looking toward the outer reaches of the universe. So you have matter. Matter's drawn together by gravity. As these nebula, gas clouds, get more compact, their temperature goes up. When they reach critical mass toward the center, you start to have fusion. The most abundant and earliest element was hydrogen. Most stars right now are made of hydrogen converting to helium. So nebula collapses, hydrogen toward the center, critical mass is met, hydrogen fuses to helium, you have a star. Debris around in that nebula. Planets. Well, you get this belt, and the fusion of hydrogen to helium to larger elements is how complex elements form. So stars are the furnaces for complex elements. So you have nebula, solar systems, everything's expanding from the center. Hubble proved that with the using the Doppler effect and the redshift. So this theoretical beginning of the universe starts with the Big Bang. It happened somewhere 13 to 14 billion years ago. The slide here says 13.5. I've also seen 13.8. Let's just look at approximately, the universe is approximately 14 billion years old. It's expanding in all directions as evidenced by the redshift. The Big Bang is a theory that's widely accepted, but like most theories, not proven and always changing. It's supported by some observations. Expansion is one of them. The abundance of the small elements, the hydrogen fusing to helium and then lithium, and then larger elements are scarce and made in stars. The background radiation left over from the original conversion or Big Bang are all what scientists use as evidence to support the Big Bang and how the universe was first started. Ultimately, you can see here, you have your subatomic particles forming atoms. These atoms congealed, formed larger elements, and eventually you have a more complex matter. I mentioned the universe and these huge gas clouds forming solar systems. Solar systems belong to bigger groups called galaxies. Okay, galaxies have trillions of stars in them. Our galaxy has trillions of stars in it. Again, most of space is empty. Then you have galaxies which have trillions of stars. These stars all could be potential solar systems, but still the universe is mostly empty space. There's three types of galaxies: the elliptical, the spiral, and the irregular. These star systems, galaxies, here's some pictures from the Hubble telescope. An elliptical galaxy is, they tend to be older, so they're out toward the outer reaches of the solar system. They are more organized. They're more organized. They contain older stars. Spiral galaxies, we belong to a spiral. They are the bulk of the galaxies. Then you have irregular galaxies and clouds. Some are too small to form major galaxies. Some are too young and they haven't organized yet. So the theory is irregular galaxies become more and more organized over time as they drift from the center of the universe. The redshift I mentioned, we're all heard the Doppler effect. You watch TV, you see the Doppler effect discussed on weather. If you ever been pulled over by the police for speeding, they got you on radar, Doppler. Okay, so light, I'm going to put this share on hold for a second, bring you into focus. You can see me, right? A large image. Okay, can everyone see the screen?
Yep.
Okay, so here you have an object and it's emitting light. And this light could be in all directions. It'd be in all directions. So there's your star, it's emitting light. The wavelength is the distance between two waves. And the frequency is how many waves pass by every second. So you have wavelength and frequency. Let's just say that's 4 waves per second. It's incredibly low frequency, but it's just for demonstration. It's 4 waves per second, and there's your wavelength. This is a stationary object. Let's say now we're moving the star in this direction. Here's the center of the universe. Okay, so the star's moving. The waves on one side of the star are going to be closer together because it's moving in that direction. A wave are closer together on one side in the direction it's moving, and they're farther away the direction it's moving from. Because it emits a wave, moves, emits a wave, so they're compressed in the beginning, and their trailing is larger. Does that make sense to everybody? So on the one side, it's blue. That's called the blue shift because blue light, the waves are closer together, our eyes perceive it as blue. Red light, the waves are farther apart. So a blue shift would be an object is moving towards you. A red shift would be an object is moving away from you. Because the wavelengths of blue light are close together, the wavelengths of red light are far apart. That's how the police use radar to track a car as it passes by. When the car is moving towards you, the reflections of the radar are close together. When the car is moving away from you, the reflections are farther apart. You can use the change to determine the speed. So astronomers look through their telescope and see how stars change. The wavelengths are getting wider and wider apart. They know the stars are moving away from you. So stars that display the red shift mean they're expanding. If it were the blue shift, they'd be moving towards each other. We can use that, to see how universes or galaxies spin, because you'll have the red shift when it's spinning away and the blue shift moving towards you, or planets. So the red shift and the blue shift and the Doppler effect, it's how we track weather systems, how we judge the speed of baseball pitches with the radar gun or cars that drive by. It's how astronomers judge the movements in the universe. The red shift and the blue shift, it was first described by a physicist by the name of Hans Christian Doppler. So it's also called the Doppler effect in honor of old Hans Christian. So that's how we scientists think. We know that the universe is expanding from one central point, is the observed red shifts and blue shifts, and then piecing it together. We also think we have a working theory on how stars are born and live. And we got that based on observations made by the Hubble all over the universe. Here, this is called the cradle of creation. It's a famous image from Hubble. It's a nebula, a gas cloud, and we're seeing stellar birth up in this arm. Critical mass reached, thermonuclear fusion starts, light energy is given off from the fusion of hydrogen to helium. So this is the theoretical life cycle of a solar system. You start off as a stellar nebula. We, and most stars, 90% of the stars are average. It's called a main sequence star. Now, this is not an astronomy class, but we're just, as an oceanography, we're looking at how Earth and the oceans formed. That's just the first box that we're checking off on our journey through oceanography, is how Earth and the oceans formed. So that's why we're going back to the beginning, just to get a handle on it. So there's us, the sun. We're an average star. We're what we call a yellow dwarf. We're huge, but dwarf stars are average stars that fall on the main sequence. Massive stars are just that. They're gigantic, massive stars. The stellar temperature can be determined by the color of light that emits. It's kind of cool when you have different tubes of gas and pass electric current through them. You can measure the temperature and look at the color of light that is emitted. So these have been tested again and again in labs to determine the temperature of each star, spectral temperatures. So an average star of middle age is just a yellow star. That's us. We're the yellow star. Red giants, as it starts to die off, it cools, and red is a cooler color. Even though red hot, you turn on your stove, it turns red. That's red hot. It would turn yellow, blue, white as it moved through the heat temperature rise. So red hot is cool for a star, but it's hot for us. So the star starts to swell as it loses energy and cool off, and then renebulizes through a supernova maybe, or parts of the gases flake off, and you're left with a white dwarf. So this is the general life cycle of what we're in. 90% of the stars are in this general life cycle. And eventually, you know, the solar system will go. It's going to be billions of years from now, so don't lose any sleep over it. Tomorrow's going to be a new day, and you're not going to lose your sun. But eventually, you know, we'll run out of energy. That's what happens. The hydrogen will be converted to helium. The helium gets converted to larger molecules, and eventually you got the supernova and the death of your solar system. Now, supermassive stars have supermass, and when they die, they leave behind black holes or neutron stars, because that mass means a lot of gravity. So that's how you would get your black hole or neutron star. So the ultimate fate of the sun would be a white dwarf, because it's not a huge star. The ultimate fate of a supergiant, maybe Rigel, which is a supergiant star that you can see in Orion's belt, it's a blue star, supergiant, could be a neutron star or black hole. Of course, we have not been around long enough to observe these cycles, because they are 12 billion years or more to go through. We just look at different parts of the solar system, solar system, I misspoke, galaxy, and see different scenarios and kind of piece it together in the order we believe that it happened. So we scientists believe that the solar system came from a nebula. That's called the nebular hypothesis. The gas cloud collapses toward the center, critical mass is met, and over time, these planetesimals or protoplanets sweep their orbits clean, and you wind up with what we have now. So collapse is the first thing that occurs. Everything's spinning. Our disks become flattened. That's the solar system's a flattened disk. And then you have cooling, and planets grow by accretion, sweeping out their orbit and growing that way. We are a terrestrial planet. We're a terrestrial planet. We're not little planetesimals. Those asteroids and things are still in the asteroid belt. We've swept out our orbit. We're inner planets, so we're terrestrial. The solar wind would have scoured away those lighter elements. Where Jupiter doesn't have the same solar wind, it's far, far away from the sun. It's much more massive, so the gravity can hold hydrogen. We're not quite massive enough. So the inner four planets, which have been scoured by solar wind, are terrestrial. The outer four are gaseous. When you look at early Earth, Marie Curie, who was the first to work with isotopes and radiation. And over time, we've learned how to use radioactive decay so we can put a time scale on it. So early Earth, we've discovered radioactivity, and we can take a look at the age of the Earth, 4.5 to 4.6 billion years old. Our oldest rocks on Earth, which are found in the center of Greenland and Iceland, are almost 4 billion years. So early Earth would have been molten. As it cooled, we had early rocks. These early rocks are toward the center of massive continents. As Earth cools, you have separation, which is called density stratification. The inner layers are far denser and far hotter than the outer layers of the Earth. I mentioned we used models last week. We've never cut the Earth in half and looked at it. So we can use models to describe the Earth. They're based on evidence. We have measurements of seismic activity. We have areas where we've drilled and we've explored. We have studied how magnetic fields are created in labs. And we piece together all the knowledge that we've had, and we come up with this model. The model is subject to change, of course, as we gather more information. But the Earth is separated into, well, we have 3 main layers, but a lot of sublayers. The first layer we call the crust, and there's 2 types of crust that we will talk about, oceanic and continental. And then we have the mantle, and you have an upper mantle or a asthenosphere in the lower mantle. Then you have an inner core and an outer core. So really you have the crust, mantle, core. Each has subdivisions. The early Earth, judging from the rocks and from the content of the mantle, would have had a lot of carbon dioxide, ammonia, methane, but no oxygen. We don't see evidence of oxygen for a while. Oxygen shows up when we start seeing rocks being oxidized and the first fossils, first microfossils. Scientists believe that oxygen comes from photosynthesis. The first oxygen was microorganisms photosynthesizing. Fossil evidence appears that way too. So here's our no real atmosphere. We're a ball of molten. Then we start to condense. We get an atmosphere, the early atmosphere, methane, nitrogen, water, carbon dioxide. Oxygen start now. There's evidence of oxygen even older than 3 billion years ago, but not much. Some rusted formations showing oxidation. Oxygen really starts to build up in the atmosphere about 2.5 billion years ago. 2.5 billion years ago, oxygen becomes a thing. The evidence of oxygen is also goes along with the evidence of early life. What comes out of volcanoes today and what came out of volcanoes then, we can assume are very similar. You get water, nitrogen, hydrogen, carbon dioxide. So our early atmosphere and all, I would say most of Earth's water came from outgassing of volcanoes. There's some cosmic contributions via comets and sweeping out the orbit of water, but the majority of our oceans came from volcanic outgassing. So make note of that in future exam questions. Where did the oceans form or how did the oceans form? The majority of that would have been volcanic outgassing. And the oceans probably, because the Earth was hot, would have evaporated and condensed several times in this early tumultuous ocean formation. So scientists postulate that oceans came from volcanic outgassing and precipitated several times and were added to by comets, but that wasn't the major contribution. The early life is over 3.5 billion years old. It was single cell bacterial, photosynthetic, and this early life also is where early oxygen is found. like I said, there's evidence of oxygen 3 billion years ago and 3.5 billion years ago, a little older, but it didn't become a thing until about 2.5 billion years ago, where it was abundant. So photosynthesis of bacteria. When I was a student, it was called blue-green algae. Blue-green algae, now it's called cyanobacteria because we didn't have the evidence or the knowledge of it. Bacteria lacks nuclei. They're prokaryotic cells. And blue-green algae, well, algae is a advanced cell structure, but this blue-green algae is now considered a cyanobacteria, and that's the early life. They condensed in these reefs called stromatolites. Stromatolite is the oldest fossils that we have. They date 3.5, even older, billion years ago. They are the major life form on Earth for 2 billion years. They are cyanobacteria. We used to call it blue-green algae. They're still around today. Here's modern stromatolites at Shark's Bay. And old fossils, you can see that they're layered, and these layers show oxidation. Oxidation is only possible with oxygen. So if you believe, scientists believe there's no oxygen, now we have oxidation associated with bacterial reefs, it has to be photosynthesis. Someone could come along and prove it wrong, and they'd have to change their theories. But the theory today is that oxygen was first provided by ancient bacterial reefs. We call them blue-green algae as well. So you could get algal reefs or bacterial reefs, depending on the text. And the buildup of oxygen started 2.5 billion years, although oxygen is older than that. Eventually, there became enough oxygen for cellular respiration, and then multi-celled complex life was enabled. So this necessary first step for complex life was the creation of oxygen, because respiration, anoxic respiration, only yields 2 ATP, doesn't yield much, not much energy. Big organisms like us and whales and seals, that's not enough energy to survive. Anaerobic, that's anaerobic. Aerobic respiration, 36 ATP, 36. That's a lot. That's a lot more energy. Complex life is possible with an oxygenated environment. So, you know, scientific thinking is when there was enough oxygen, we started having the evolution of life. So in the history of oceanography, when we look at it, we're going to gloss over this because we discovered, we discussed this last class, what a hypothesis was, what a theory was, and what a law is. So we talked about this last class. If there's any questions, feel free to ask me. And we also discussed the scientific method last class. So we'll skip over that and move into the first evidence of oceanography. Middens are very interesting. I did a study on the history of Florida. We have these middens. Middens is just a garbage heap, or that's a kitchen midden, garbage heap. Ancient people would build mounds and then build their house on them. And then you dig through the middens and you'll find fire pits. You'll find what they ate. You'll find pottery and art, and you can trace their history and interactions. So man's interactions of the oceans come from studying these middens. We know that the first Americans came over that Bering Straits and moved down the coast following the California current, abundant food. And we can tell that by carbon dating the middens of people. And you can see how they moved and look at what they ate. See that they were tied to the California current, which is a nutrient-rich current, Pacific Ocean, down the west coast of North America. And the foodstuffs that they ate, they were dependent on the ocean. So these middens are studied by anthropologists, cultural, studied by scientists, oceanographer, to see how dependent the early humans were on the ocean. So the middens are from culture. So we know oceanography, the study of the oceans, started with the first Americans or before that. Any civilization that was near the ocean was dependent on it for food, for transportation. The Egyptians and the Mesopotamian cultures had trade. They used the oceans. The Minoans were the first to be able to use maritime sail power. Phoenicians and ancient Greeks colonized the Mediterranean Sea and actually studied it. And the Polynesians colonized the South Pacific Islands. So early humans used the oceans and they charted the oceans. They mapped the oceans. Here's an early chart. Granted, they did not have the extensive knowledge of the oceans, but the oceans were charted. So the Phoenicians, the Greeks had charts. This is the world known in 450 BC to the ancient Greeks. And you can see it's not the whole world, but there's parts of Europe, parts of Africa and Asia, the Mediterranean Sea. Then you have the Mar means ocean, Atlanticum, the Atlantic Ocean. And down here, what we know now as the Indian Ocean was not then, was not called, there's India right there. So this was if you happen to be ancient Greek or living in the Nile area, this is what you knew of was the world back in 450 BC. So early Greek ideas, Aristotle was the first to categorize and catalog organisms. He used animal, vegetable, mineral, air dweller, land dweller, water dweller, so very rudimentary characterizations, but that's what taxonomy does, categorizes organisms. Aristotle was one of the first to do it. Eratosthenes, who was one of the librarians at the Alexandria, he calculated the circumference of the earth, calculated the circumference and that the earth was a sphere, and a whole slew of other things. He used geometry. Geometry is the study of the earth and angles to do that. We find a slew of Polynesian maps of the South Pacific, Phoenicia and Greek maps of that Mediterranean and area there. Pardon me. The first lighthouses were built in Alexandria, and one of them is one of the 7 wonders of the world. Star patterns, constellations, were studied by ancient Grecians, and we know that North Star and other reference stars are used for navigation. Now, European exploration discovery was a little bit bigger. Generally, trade, gold, and things like that fueled that. Also, colonization. The first school for navigation was founded in 1420. And then Europeans didn't really discover these, but they were discovered before, then rediscovered by Europeans. You know, Columbus for many, many years was credited with the discovery of America, although there were 2 groups of Americans before, the natives who came across the Bering Sea, and the Vikings who went around that Arctic Ocean, Iceland, Greenland, Newfoundland, and then down the Great Lakes region, So really, he didn't discover it, but he was one of the first Europeans to make it there. Magellan was the first credited to circumnavigate the world, which means go around the world. He died in this trip, so he didn't make it around the world, but he's still given credit for it. And Francis Drake was given credit for it several years later. Some of the important voyages, here's Columbus's first voyage, where he never really made it into North America. He only made it into the Caribbean island arc in Cuba. So he never set foot. The Vikings had been there, first Europeans. And of course, the natives came across the Bering land bridge. They were there way before, but Columbus is still part of our history. Magellan, like I said, he was the first credited to circumnavigate, but he did not make it. He was killed in the Philippines on this voyage, so he missed the entire last leg. Captain James Cook was credited with discovering Australia, Hawaii, and New Zealand, although Aborigines lived in Australia and New Zealand, and the Polynesians lived in Hawaii. We will give a tip of the hat to Darwin and the Beagle, Charles Darwin, for natural selection and atoll formation. The Beagle was a ship that went around the world studying it was scientific knowledge. So here's Cook's and his voyages. Captain Cook is credited, although he's not really the discoverer, we know that he's credited with Hawaii, New Zealand, Australia. So he's a big whoop-de-doo when it comes to that. Here's Darwin, and he's credited with natural selection and the origin of the species and atoll formations, how coral reefs form. His voyage was 5 years. And you can see right here where my cursor's over, that's the Galapagos Islands. We discussed that last time, but here's the trip that he made around South America, across the Pacific, around Australia, around Cape of Good Hope, and then up. The Challenger was the first deep ocean expedition in the 1800s. They didn't have sonar. Sonar was invented during World War II. They just used plumb bobbing, but they measured the deep ocean. So ocean mapping, the first echo sounding was done in 1925. And then, of course, post-World War II, when we have echo sounding and echolocation, very sophisticated, not just a ping, but multi-beam and things like that. We can map the ocean floor. Plate tectonics, although introduced in the early 1900s by Alfred Wegener, and we're going to discuss plate tectonics next class, wasn't accepted until the late 60s when deep sea cores drilling proved that the ocean floor was spreading at spread centers. The Challenger expedition in the 1700s, here's the route. It's credited, it's the first deep ocean. They discovered the Challenger Deep at Mariana Trench, and they also discovered nearly 4,500 new deep sea species. Scientists did not know life could exist without sunlight, so they discovered nearly 4,500 species that weren't light dependent. So it was a pretty big historic voyage in oceanography. The Glomar Challenger, which was named after the HMS Challenger in its honor, was the one that proved continental drift and plate tectonics using ocean cores, because those were a decommissioned deep sea driller. So they drilled into ocean sediments and dated them and found the ocean floor spreading and being lost at subduction zones. The ocean floor itself, you're going to be hard pressed to find more than 200 million years of data because it's being constantly recycled, created at spreading centers and destroyed at subduction zones. If you hearken back to last lesson, we discussed how subduction pushes the ocean floor under and remelts it. So the ocean floor is young, the continents are old. Here's the first bathysphere that made it in the deep. The deepest in 1934, the bottom of the ocean, not Challenger deep, but it was made over 3,000 feet deep by William Beebe. Barton invented the bathysphere, although diving bells were used as early as Aristotle's days, where they put a glass bell over somebody and put them underwater, and they had a little bit of air, but they couldn't go deep, obviously, but you could make observations. Now, sonar became popular during World War II, and then after World War II, the entire ocean floor was mapped using sonar. Scuba was invented by Jacques Cousteau and Emily. There they are. Compressed air. They called that the aqualung. Cousteau and Cousteau Society is still famous today. One of the first deep sea submersibles, Elvin, discovered ocean vents. They also used Elvin to do the Titanic excavation. So Elvin is one of the famous submersibles. Hui, Woods Hole, that's East Coast, very famous oceanography center, Hui. West Coast, Scripps is the big famous oceanography center. Satellite technology now can map the ocean floor as well. That's what I said, Woods Hole, Hui. That's East Coast, and Scripps is West Coast. The federal branch that studies the oceans is NOAA. NOAA, the National Oceanic and Atmospheric Administration. So that's the federal branch of ocean study. So that's a brief history of our planet, how oceans formed, and who studies the oceans and how we study the oceans. It's not comprehensive. Please read the chapters in the book to get a little more detail, but it will be sufficient for the first quiz. Don't take the quiz until after Wednesday's class, because I'd like to teach you about teach you about the plate tectonics and such beforehand. But start working on this article. Find a couple of articles. Make sure you get the discussion forum done, and make sure you get the discussion forum. Make sure you get that flowchart submitted by Wednesday as well. I did have a couple of people that had some questions. They wanted to hang back, but at the moment, I'm going to dismiss class. Those people who want to hang back, just hang back for a minute and let people clear the room, and then I'll handle everybody's questions individually after that. So those who don't have any questions, I will see you Wednesday. And those that do, just give it a minute or so, hang back, and then once the room clears, we'll address each one of you guys individually, okay? So have a great day for those who are leaving.
Thank you for lesson. May I ask this?
Just a second until the room clears, and then I'll handle everybody individually, okay?
Thank you.
Okay. Maria.
Yeah,
Yeah,
Okay.
yeah, that's you.
thank you. 2 paragraphs we have finished before the next lessons, before the Wednesday, August
What are
25.
you talking about?
2 paragraphs
For what? Which assignment are you referring?
about well, where is I writing? So many
This
writing.
Wednesday.
So much writing.
Okay, this Wednesday, 2 days from now, right?
Yes,
Have your discussion forum that's due
yes.
and your flowchart assignment.
Okay. Okay, that is. And next questions. Weekends comes before the Columbus to
I
US.
didn't understand what you just said. What was that?
About Viking, who first come to the USA. No, we talk about Columbus, discover America.
No,
and,
no, no, no.
what is it?
Columbus was the third group to make it. The first natives that crossed the land bridge over the Bering Straits. The second were Vikings.
Second Viking.
Yes.
Okay.
Okay.
Yeah, it's third Columbus.
Columbus and the Europeans, that's the third that I know of, yes.
So, first one, I'm sorry.
The natives across the Bering Sea.
Native, some people.
The original Americans, the Native Americans, the Inuit across the Bering Sea.
The Americans lives here before the Vikings comes.
Yes. There were
Oh,
people here before the Vikings, yes.
Okay. Thank you.
Mhm.
Thank you. Have a good day.
You too now, bye-bye. Anyone else?
Hey,
I'll go. I think you already answered this question. I just wanted to make sure.
Wells, right? Wells?
Yeah, Wells.
It's Wells, is
I'm-
your first name, right?
Yeah, that's my first name.
Excellent. Okay, Wells, what can I do for you?
I just wanted to make sure for the assignment due next Wednesday, 9/1.
Yeah?
The I forget what it's called actually, but the one where
The
you
current
research
events?
article. Exactly. Thank
Yeah,
you.
okay.
It's two paragraphs per article, right? A body and a
Correct.
conclusion.
Yes. Yep.
Okay.
All
great,
the
thank you.
directions are spelled out, so when you go through it, it should be easy to remember.
Okay. Thank you.
No problem.
You ready for me, Doctor?
I'm ready for action. What can I do?
Okay, here we go. If you look at the picture of me on the screen, you could see I'm a senior.
Oh, seniors only, that's okay. I'm a senior too, so.
Okay, the question and what I'm trying to raise the question is, I'm not doing this for credit. I'm not doing this for a certificate. And I'm not wanting a grade. So can I just audit? And if I miss some assignments, I don't want to be,
No, that's cool.
so,
I never expected you to turn anything in.
okay, I'm trying to be, let me put that on, hold on.
No, you told me that you were just here to enjoy yourself and listen to the lecture and poke around. So I wasn't expecting you to turn anything in. It's fine.
Okay, so let me ask the following. By the way, I very much enjoyed the last 2 lectures and very informative. And so I'm happy to be an audit in this class.
Excellent.
But the question I raise is, I wound up finally buying a rental book
Right?
of the particular author that you're referring to. And I read the first chapter, which was the assignment for today. And when I listened to your lecture, there were little pieces in your lecture that I could track to the text in the book on chapter 1.
Right?
A lot that was not in there. And my question is, what is your source for all those wonderful slides?
Well, I actually studied oceanography back in the 90s. So it's a lifetime of building up knowledge.
Well, that's great. But in other words, I just gotta find my way back to your Zoom lecture and
Right.
find a place where I can actually view it and listen to it.
Well, can you see the screen I'm on right now?
Yes,
That's our course home screen. Now,
yeah,
you click on the course content and you see that opens up. I go to the table of contents to simplify. And then here's our Zoom stuff right here under Zoom videos. These are the videos. They have been posted. When you click on one, you can see there's the video. It's an hour and 24 minutes of brilliance, I guess, or for lack of a better term.
well, that's where I got frozen out. It stalled out and I couldn't listen. So I gotta go to the library. Maybe they have a better internet Wi-Fi issue connection to listen
Morning.
and take
Okay.
some more notes.
Okay,
Yeah, that's basically my, thank you, doctor.
no problem. You have a great day, sir.
You too. Okay, well,
I see that you're here. How can I help you? You're waving, but I don't hear you.
Oh, yes, me.
Now I hear you.
Yeah. Okay. Oh yeah, when I emailed you about the flowchart assignment that I done the flowchart on paper,
Right?
and I did the conclusion, the summary on the computer. And
Okay.
I kind of sent it on Dropbox.
Well, all you gotta do is take a picture of the one you did on paper and submit the picture, and now I have it.
Okay.
Perfectly good. Picture right from the phone, submit that, you're good.
Thank you.
No problem.
All right. See you Wednesday.
See you Wednesday.
Yeah.
bye-bye.
Bye. I got Alejandra, are you there?
Yes, I am.
Can I help you?
Yeah, I don't know how dumb of a question this is gonna, or I don't really know what exactly it was. It had to do with the book. Were we ever given an access code for that? Is that something that we've got to buy?
Yeah, the textbooks are for sale, yes. I don't mind if you get an earlier edition if you're trying to save a little money, but the information is in the syllabus as far as I can only recommend the bookstore and I can only approve the one listed in the syllabus, but I can say, you can seek other vendors if you wish for a little better price.
Well, right now I have a screen pulled up with the Pearson thing saying Pearson eText Essentials
Yes.
Oceanography, and it says you can redeem an access code or buy it for about $40.
Right, well, you would have to buy the access code. You get the access code from the bookstore, or you would go to pearson.com and buy it, but the access code is something that you purchase.
Okay. And would buying it just online just give me the book in like a digital format?
Yes, or you could buy a hard copy and they'll mail it to you.
I think that was all.
Okay, well, if you have more questions, just shoot me an email.
All right.
Okay,
Thank you.
yep, have a great day.